Hello, my name is Chris Roberts, and I'm a senior biochemistry major at the University of North Carolina at Greensboro. Fungal infections are a challenge we as humans have to deal with. From athlete's foot to ringworm, they're everywhere. One fungal infection that is unknown to most people is Aspergillosis. Aspergillosis is a broad term for any infection caused by the Aspergillus genus. Most Aspergillosis is relatively common and only mildly affect people with asthma or any similar conditions, but when Aspergillosis becomes invasive, it can be fatal, but usually only occurs in immunocompromised people or people getting a transplant. Aspergillosis is mainly caused by the species Aspergillus fumigatus. What is interesting, though, is that two closely related species, Aspergillus fisheri and Aspergillus olingacensis, do not exhibit the same virulence as Aspergillus fumigatus. One possible reason Aspergillus fumigatus has such a high virulence is the metabolite it produces. One example of this is gliotoxin, which is a metabolite that is very toxic to humans. The purpose of the study was to determine if there was a huge difference in secondary metabolite production between three species. To examine the metabolite production of each species, multiple strains of each species were grown on oats for approximately 2 weeks at 30 degrees Celsius and 37 degrees Celsius to mimic body temperature. As shown in Figure 1, the fungal cultures were extracted with a mixture of chloroform and methanol and then filtered. The resulting crude extract went through several purification steps to yield the defatted extract. These extracts went through further purification with high-pressure liquid chromatography to yield pure compounds. Also, the defatted extract went through liquid chromatography and mass spectrometry analysis so the overall metabolome could be analyzed, and the metabolites that were barely produced could be seen. The defatted extract was chosen because it contains most, if not all, of the metabolites of interest. In the analysis, all the peaks and all the masses associated with them were recorded, as well as the relative amounts of each peak. Using a clustering program, the different species were clustered based on the different peaks present and how well the relative amounts correlated with each other. As shown in Figure 3, what was found is that all species biosynthesize gliotoxin. Gliotoxin is a known immunosuppressant mycotoxin and is known to be very toxic. However, species differed in the production of fumagillin and serotin A, both contributors to host tissue damage during invasive aspergillosis. Only Aspergillus fisheri and Aspergillus fumigatus produces serotin A, and only Aspergillus fumigatus produces fumagillin. This discrepancy in the production of these three compounds can be used as an example of where the difference in virulence arises from. The whole metabolome was analyzed in Figure 4. At first glance, the chromatogram showed a clear difference between Aspergillus fumigatus and the other two species. Qualitatively, all the fumigatus strains look similar to each other, while all the fisheri strains look similar to each other. Aspergillus olingacensis is similar to Aspergillus fumigatus, but based on looks alone, Aspergillus olingacensis is most similar to fisheri. Using the clustering program mentioned earlier, we can see that Aspergillus olingacensis and Aspergillus fisheri are more similar to each other than they are to Aspergillus fumigatus. This shows that it is possible that high virulence from Aspergillus fumigatus is from its unique secondary metabolite production. Further work needs to be done to elucidate more specific metabolite differences and similarities between these three species and more closely related species. And that can be used to pinpoint where Aspergillus fumigatus' high virulence comes from and a way to combat it. Thank you.